Imagine waking up one morning perfectly fine and by noon you cannot move one side of your body. No warning. No obvious cause. This is the reality for thousands of people under the age of 60 who suffer what doctors call early stroke, a sudden disruption of blood flow to the brain that strikes far earlier than most would expect. While high blood pressure, smoking, and poor diet are well-known culprits behind such events, science has now uncovered something far more unexpected hidden within our very biology, a clue written not in lifestyle choices but in our blood. Yes, your blood type, the simple label of A, B, AB or O that shows up on medical forms, might quietly influence your chances of having a stroke long before old age. Not in a dramatic or guaranteed way, but in a subtle yet measurable shift in risk that could help explain why some otherwise healthy individuals fall victim to this life-altering event while others do not. For decades, blood types were seen as little more than compatibility tags used during transfusions. But modern genetics has revealed they are much more than that. These classifications stem from tiny chemical markers on the surface of red blood cells, controlled by a single gene with different versions passed down from our parents. What scientists have begun to realize is that these same markers play roles far beyond transportation of oxygen. They appear to influence how our blood behaves, especially when it comes to clotting. A major study combining data from dozens of research efforts around the world has found a consistent pattern. People with one particular variation of blood type A face a noticeably higher chance of suffering an ischemic stroke, the kind caused by a blocked artery, before reaching their 60th birthday. The increase is not massive, but it is real and repeatable across populations in North America, Europe, Japan, Pakistan, and Australia. Even more telling, this link disappears in those who have strokes later in life, suggesting that early strokes may follow a different biological path than those occurring in older adults. Why would blood type matter at all? The answer seems to lie in the sticky world of coagulation. Blood must walk a tightrope between flowing smoothly and clotting quickly when needed. Too little clotting leads to dangerous bleeding. Too much raises the risk of clots forming where they should not, like inside a brain artery. The ABO gene affects levels of certain proteins involved in this balance, particularly one called von Willebrand factor, which acts like glue in the clotting process. People with type A blood tend to have higher baseline levels of this substance, making their blood slightly more prone to clotting under certain conditions. Add in other silent triggers, a minor injury, dehydration, an undiagnosed heart rhythm issue, and that small tendency can become the spark that ignites a stroke. This does not mean everyone with type A should panic. Stroke remains rare in younger populations, so even an elevated relative risk still translates to a low absolute danger for any one person. Think of it like weather patterns. Just because a region has a slightly higher chance of thunderstorms does not mean every summer day will bring lightning. But for researchers, this signal is invaluable. It points toward a deeper truth, that some strokes in young people may originate not from years of wear and tear on arteries, but from inherited quirks in how blood behaves at a microscopic level. In contrast, those with type O blood seem to have a bit of natural protection. Their bodies produce less of these clot-promoting proteins, giving them a modest edge when it comes to avoiding premature blockages. Meanwhile, another surprise emerged. People with type B also showed a raised stroke risk, though this time across all ages, hinting at a broader influence that extends beyond early onset cases. This adds to growing evidence that the ABO gene is not just about blood matching but plays a quiet but steady role in cardiovascular health overall. What makes this discovery truly significant is what it reveals about the nature of stroke itself. For years, medicine has treated stroke as a single condition, largely driven by aging and lifestyle. But the differences between early and late events suggest we may need to rethink that view. Strokes in older adults typically result from decades of plaque buildup in arteries, a slow clogging akin to rust in pipes. These are heavily influenced by cholesterol, diabetes, and hypertension. But in younger people, the story often looks different. Many have no obvious arterial disease. Instead, their strokes appear linked to sudden clot formation, sometimes triggered by factors we barely understand, genetic predispositions, immune responses, or even seemingly harmless infections that set off a chain reaction in the bloodstream. The fact that blood type only influences early stroke risk supports this idea. It suggests that clotting dynamics, governed in part by our DNA, are more central in youth, while structural damage to blood vessels dominates later in life. This distinction could eventually reshape how doctors assess risk. Today, prediction tools focus almost entirely on traditional factors like age, smoking, and blood pressure. Tomorrow, they might include genetic markers like blood group, especially for younger patients with unexplained symptoms or family histories of early stroke. Of course, there are limits to what we know. Most participants in the study came from Western countries or East Asia, with underrepresentation from African, indigenous, and other global populations. Since blood type distributions vary widely among ethnic groups, for instance, type B is more common in parts of Asia and Africa, future research must expand beyond current datasets to see whether these patterns hold true everywhere. Additionally, while we can observe the association, we do not yet fully understand the biological bridge between the ABO gene and stroke. Is it only through clotting factors? Or do these blood group markers also affect inflammation, vessel wall integrity, or immune signaling in ways we have not yet detected? Still, the implications ripple outward. Consider someone in their 30s experiencing dizziness, blurred vision, or sudden numbness, classic stroke signs that are often dismissed because the person is too young. If doctors begin factoring in blood type as part of a broader risk profile, such warnings might be taken more seriously. It could lead to earlier imaging, closer monitoring, or preventive advice tailored to individual biology. It may even inspire new treatments aimed at modulating clotting activity in high-risk groups, much like statins are used to manage cholesterol in those prone to heart attacks. None of this changes the basics of prevention. Eating well, staying active, avoiding tobacco, managing stress, and controlling blood pressure remain the foundation of brain health. But this discovery reminds us that medicine is moving toward a more personalized future, one where your unique genetic makeup helps guide care. Just as some people learn they carry genes linked to cancer or Alzheimer's, someday it might become routine to consider blood type not just for transfusions, but as part of a lifelong health forecast. And let us not forget the mystery that still surrounds blood types themselves. Why do they exist in such variety? Evolutionary biologists believe these differences may have arisen as defenses against ancient pathogens, perhaps offering protection against certain infections at the cost of slightly increased cardiovascular risks today. Type O, for example, appears to offer some resistance to severe malaria, which could explain its high frequency in regions where the disease once thrived. So in a sense, what protected our ancestors may now subtly influence our modern health challenges. The takeaway is not fear, but awareness. Knowing that something as simple as blood type can play a role in stroke risk empowers us to look deeper, ask better questions, and push science toward answers that benefit everyone. It highlights the intricate web connecting our past, our genes, and our present health. More importantly, it underscores that stroke is not just a disease of aging. It can strike anyone, anytime, and sometimes the clues lie within us all along. So next time you donate blood or get a routine test, and that little label appears, a positive, O negative, AB, remember it is more than a category. It is a piece of your biological story, one that may one day help doctors protect your brain long before trouble starts. Science is beginning to read between the lines of our blood, and what it finds could change how we think about prevention, timing, and the very nature of disease. In the quiet code of our cells, a revolution in understanding is underway, one drop at a time. If you found this video eye-opening, don't keep it to yourself. Hit that like button, subscribe, and share it with someone who needs to know that health isn't just about choices. Sometimes, it's written in your blood. Drop a comment below. Did you know your blood type could play a role in your stroke risk? Stay informed, stay curious, and most importantly, take care of your mind and body. See you in the next one.